Well, good morning, everyone. I'm Mark Collier with the OpenStack Foundation. I'm happy to be joined by Lauren Sell. And we're both on Twitter, so if you're into that, you can follow. Make sure you follow Lauren. She loves Twitter. So, first of all, I think it's appropriate to start with a congratulations for I know many of you are tired if you stayed up and watched that last night. So let's talk about OpenStack. First of all, OpenStack adoption continues to grow all over the world. And based on our user survey, we've now determined that over 10 million cores of compute are managed by OpenStack all over the world. And the reason we are able to track this metric is because of the OpenStack user survey. This is a very important survey. Any of you who use OpenStack, please take the survey. It's openstack.org/user survey. It's open now for about another month. So now's your time to take the survey and help us raise that number even more, millions of cores more. We also have seen that based on analyst data and surveys done by analyst firms, 71% of service providers have indicated they're already in production with OpenStack or they're planning to go into production in the next 12 months. The market opportunity just in this year alone is estimated to be over $6 billion. I'm not sure how much that is in won, but it's a lot. So big market opportunity. And when we talk about the OpenStack software, one of the things we've done is created a map. This map helps everyone understand a little bit better what's going on inside of the OpenStack community. There are many different projects. Oftentimes it's difficult to learn about them, and this map helps give you a little guidance. It puts the projects into different categories so you can see which tools are for operators, which tools are for end user services, and which tools help connect to other projects and other tools like Kubernetes, etc. Now, in terms of Nova, which is a very popular component in OpenStack, in the last release of OpenStack, support was added for vGPUs. GPUs are extremely popular these days, not just for Bitcoin mining, but also for AI and machine learning and many other use cases. So having that support in Nova is very important to many users. A couple of other notable improvements that are happening in the OpenStack software are fast forward upgrades, in which you have the capability now to go from one release, several releases, upgrade at a time. And in combination with another new capability that the community is doing with your help, which is providing extended support for maintenance branches. So a lot of users have told us they don't necessarily want to upgrade every 6 months. They may run an older version for a while that's older than 18 months. And this allows the community to provide support for those stable branches. And then when the user is ready to upgrade, they can upgrade with fast forward to many versions at a time. So those two together represent a lot of work in response to what users of OpenStack have asked for. Now, what users are doing with OpenStack is really interesting. A lot of the infrastructure we all rely on every day, everything from planes, trains, and automobiles are powered by OpenStack in some way because of these companies and these industries relying on OpenStack. And these are OpenStack deployments all over the world. It's a very global open infrastructure movement built on OpenStack as a foundation in many countries all over the world. We also see the use cases vary from science, various forms of scientific research, to some of the business use cases that are very important as well. Now, when we think about what people want out of OpenStack and out of cloud and out of infrastructure, what we see today is much different than 8 years ago when we started OpenStack. People expect their cloud now to do a lot more. So AI, machine learning, containers, serverless, all of these capabilities are expected now in infrastructure that's automated. And these users are expected to deliver that for their organizations, these operators, and they're doing it in more places. So not just data centers, but out at the edge. And another interesting trend is that the different diverse architectures that people are turning to solve the unique problems of infrastructure at scale. So it's not just x86, it's ARM, Power, of course GPUs, and FPGAs. I was just talking to one of the large telcos recently about how they're adopting FPGAs to do workloads 5 times more efficiently than on a traditional architecture. So this is a big trend, and on top of all the hardware diversity, there's more open source than ever that's really driving cloud computing. And so when you put together not just the OpenStack components, but all of these other pieces that people are assembling, there's a couple of big takeaways. One is that there's a myth that cloud is consolidating. That is absolutely not true. In fact, cloud is not consolidating, it's diversifying. And this is something that a lot of people, are just starting to realize. If you think about the early days of cloud, it was assumed that everything was going to be commodity hardware and it was all going to be very homogeneous, and that's not the way it's turning out. And in terms of how these problems are getting solved, we find that everywhere you turn, AI, machine learning, container, serverless, each of these trends is being powered by open source because open is a better way to solve problems across organizations, across countries. And even with all this open source, we also see that open source itself is not enough. If you want to turn open source into open infrastructure, it takes more than just the code. You actually need to integrate and operate all of these pieces together. And so as a community and as a foundation, as an OpenStack foundation and as a community, we are the people who really are the right group of people to solve these challenges, all of you, along with the rest of the global OpenStack community all over the world. And so this group of people that build and operate infrastructure that's open are a lot of large and small companies all over the world, big brands that you may have heard of. And one of the things that we've learned as a community is that logos like these do not actually operate infrastructure. It's actually the people that are really the important part of the community. These are the people who actually operate the infrastructure, and it's the heart and soul of our community and how we make progress on these hard challenges. As an example, this is the 4 people at Adobe Marketing Cloud that operate a cloud with over 100,000 cores with just 4 people. So that's a sign of how important it is to have the right people with the right knowledge. And Joseph Sandoval, who's pictured here along with his team, is one of the leaders of this movement, and he's someone that who'd be great to get to know if you get the opportunity. Eli Elliott is another leader in the community who works for Gap, and he's integrating OpenStack and Cloud Foundry. So again, we see people putting together different components from OpenStack community and many other communities like Cloud Foundry. And Ricardo Rocha from CERN, he operates more than 200 Kubernetes clusters on OpenStack. There are many people who want to run Kubernetes on OpenStack or combine the two in some new and interesting ways. We'll be hearing from throughout the week here. And CERN is certainly one of those great examples. So in light of all this diversification and the many different software and hardware components, what is our strategy really as a community and as a foundation to rise to that challenge? So to talk to us about that, Lauren Sill.
So last year, we really started to think differently about our strategy. In the past, we thought about infrastructure through the view of OpenStack, the project, but we realized we need to be thinking about it through the view of our community, the people who operate infrastructure, because they care about OpenStack, but they also care about a lot more than OpenStack. They're having to integrate many different technologies, different architectures to solve new use cases. So we needed to be thinking from their perspective. And we realized that one of the biggest challenges to open source and open infrastructure is integration. So the end of last year, we announced we talked about a new strategy to help support that, to help improve integration of these technologies. So we defined 4 steps for integration, and today I want to talk through what we think those 4 important steps are, and also a lot of the progress that we've made in the last 6 months, because the community has been doing a lot of work, including many people in this room, so we want to share that work with you. So the first step is identifying the common use cases. This is, any time that you're going to build technology, you need to have a reason or a business case, a use case for that. And one really important example of that we actually launched in May is a white paper about containers in OpenStack. So it's about different organizations, including SK Telecom, who are using OpenStack along with technologies like Kubernetes and talking about their architectures and how they're integrating these technologies. And you can find that white paper online as well on the OpenStack website. And another example of that is an Edge Cloud white paper. So there's another working group in the community, the Edge Cloud Computing Working Group, who helped put together a white paper about Edge Cloud use cases. And that white paper was developed by many different organizations in the community. And I wanted to point out Ildiko Vansha, who's here from the foundation. We actually have several people here from the foundation today that want to meet all of you and learn what you're doing and share what we're working on. But if you're interested in getting involved in edge computing or have those use cases, this is a good place to get involved.
Yeah, actually, this is probably a good time to point out that Chris Hodge is here also, who's one of the experts in containers. So in the, oh, did I steal your thunder? Sorry.
Okay.
Forget I said that.
Yes. So the next step to that, in terms of after you define the use cases, you also need to then collaborate across those communities. So the different technologies that we're talking about putting together, we need to go out and build relationships with those open source communities and figure out, what those gaps are to integration and help work on those together. So one important example of that, again, referencing the Edge Computing white paper, is the different organizations that we collaborated with, like OPNFV and Etsy, to help define those use cases and architectures. And then as Mark pointed out with Chris here, we've done a lot of work upstream in the Kubernetes community as well, because we think it's really important not just to invite other communities into the OpenStack world, we have to make the effort to go work in their communities. And we've invested resources to contribute upstream in Kubernetes, and we think that's very important. And again, if that's something that you're interested in, Chris is a very good resource here at the event.
Chris Hodge is here.
Oh, I messed up on the slides. So the third step, after you've defined those architectures and you've gone out and worked with these different communities and projects, you may find that there is still a gap. And in some cases, we do need to build new technologies or potentially host new projects to fill those gaps. So last year, the OpenStack Foundation has been hosting the OpenStack project since 2012, when it was formed. And last year, for the first time, we added a new project that was separate from OpenStack, hosted underneath the OpenStack Foundation, called Kata Containers. And then we also added, this year in May, another new project called Zool. So today we're going to talk to you a little bit about these projects, and then also give you a preview of some projects that are coming down the pipeline, which include a project called Airship and Starling X. So first I'm going to give you a quick overview of Kata Containers. the idea behind Kata containers is to give you the speed of containers, but with the security and the isolation of virtual machines. And with Kata containers, the isolation is done through virtualization instead of namespaces. And the technology was formed, there were actually two different open source projects. One led by a startup out of China called HyperSH, and the project is called RunV. And another project which was developed by Intel called Clear Containers. And both projects were doing very similar things, so they decided to merge and try to form an open standard for this technology. So one really interesting thing for us is the architecture committee that is working on this project. This is new for the OpenStack Foundation, that we have organizations like Google and Microsoft taking technical leadership roles on these projects. And we think it's a big opportunity for our community to really broaden the scope of open infrastructure and be able to work across all these organizations that are very important to our users as well. And the first release of Kata containers was just a few weeks ago in May. If you want to go take a look at the code, they would definitely welcome your contributions and getting involved. And you can find more information at katacontainers.io. So Kata containers was the first project that we launched, and now Mark is going to talk to you about Zool.
All right, so I guess we'll just hand the mic off. So Zool is really interesting for us as a new project because it's actually 6 years old. But it's new for us to be talking about it as a top-level project within the OpenStack Foundation. And Zool has a really interesting slogan or motto, which is "Stop merging broken code." And anyone who's out there who writes software would probably love to stop merging broken code. It's certainly a headache for many people that they'd love to be able to solve. So the reason why Zool is 6 years old, even though we're also talking about it now for the first time, is because this is a tool that was built by the OpenStack community for the OpenStack community. So this was a tool that was built that's fundamental to how OpenStack as a piece of software gets developed and tested. And it is a CI system, meaning a continuous integration system. And it has been proven at scale because it's served the OpenStack community, which is one of the largest open source projects ever, with thousands of developers in over 100 countries. So with a challenge like that, the existing tooling really couldn't meet our needs. So the OpenStack community created Zool. And it does test many, many thousands of jobs. And this is part of why a lot of other organizations and other people developing software have expressed interest in it and said, can we use it for our software development? So what is Zool? I mean, it's really an automation system that's focused on gating. So the idea behind it is that every change to a piece of software that's being developed should be a commit, and every commit should be tested. And when there are related changes that are coming in from many developers all over the world, they should be tested together. And when there are complex actions that the software is expected to perform, there should be end-to-end testing. So a lot of the existing CI tools couldn't quite meet the needs of the scale and distributed system and distributed teams within OpenStack community. So Zool was created to address that challenge. And Zool is really about continuous everything. So all of the jobs are written in Ansible, which is a very popular automation language or framework. And the configuration is very dynamic and supports both Gerrit and GitHub workflows. And one of the reasons why we're talking about Zool now, even though it's 6 years old, is because it's on version 3. So the third version of the software was really designed to work outside of OpenStack. So OpenStack, of course, still uses it. Our community uses it every day. All around the world, code commits are coming in and being tested and gated with Zool, but many other people want to use it with their tools. So version 3 made it much less sort of hardwired to the OpenStack workflow, it allows it to support things like GitHub and things like that. So if you develop software and you want the quality to be better and you want to stop merging broken code, you should definitely check out Zool at zool-ci.org and get involved. It's an exciting project developed here in the community. So the next project is?
So the next two projects are very early stage. So OpenStack and Kata containers and Zool are all top-level projects within the OpenStack Foundation now. But at the last OpenStack Summit in Vancouver in May, we started talking about two new projects that are very early. We're just starting to build community around them. And we want to give you a preview today and see if you'd like to get involved. So the first project is Starling X, and this project is focused on edge computing and industrial IoT. It was seeded with code from Wind River and Intel, and we're just starting to form the community around it. The mailing list is very active right now, so if you're interested in those topics and areas, I would encourage you to go to the website and join the mailing list and get involved.
All right. And you know, one of the great things about these new projects is they're very much led by users for users, so they're not just technology for technology's sake or driven purely by vendors. And a great example of that is Airship, which again is very early on. You can learn about it at airship.org, but before you do that, I'm excited to bring up Jasek On from SKT to tell us about Airship, one of the users that's driving this forward.
I don't need to speak English, right?
No.
예, 안녕하세요. 저 SK텔레콤의 안재석입니다. 그 에어쉽에 대해서 고맙습니다. 에어쉽에 대해서 간단하게 소개를 드리면 에어쉽은 그 AT&T가 주로 진행을 하고 SKT도 관련된 코드 개발을 기여를 하면서 한 달 전에 프로젝트로 런칭을 했습니다. 에어쉽이 하는 일은 사실 간단한데요. 오픈스택을 구축하는 일입니다. 근데 오픈스택을 구축하기 위해서는 지금까지 뭐 굉장히 많은 자동화 툴이 있었는데 왜 이 시점에서 다시 에어쉽이라는 프로젝트가 나왔는지 여쭤보면 오픈스택을 설치를 하되 굉장히 다른 그 방향에서 좀 접근을 합니다. 그래서 오픈스택을 설치하기 위해서 필요한 모든 것들, 깡통 서버로부터 오픈스택하고 오픈스택에 필요한 모든 모니터링이나 관련 시스템들을 설치할 수 있는 모든 파이프라인, 베어메탈 OS 설치, OS 컨피그레이션, 뭐 네트워크 컨피그레이션 이런 모든 것들을 할 수 있는 방법을 컨테이너화해서 클라우드 네이티브한 플랫폼으로 만들어 놨습니다. 그러니까 그리고 쿠버네티스가 중심에 있고요. 그래서 깡통 서버가 들어오면 자동적으로 모든 필요한 컨테이너들이 호스트 OS 설치부터 컨피그레이션, 쿠버네티스 설치, 그 다음에 쿠버네티스 위에서 오픈스택 자체를 컨테이너화해서 클라우드 네이티브 앱처럼 설치하는 전 과정을 자동으로 수행할 수 있도록 만든 프로젝트입니다. 그래서 그것들을 수행할 수 있는 이제 서브 프로젝트들이 유기적으로 전부 다 연결이 돼 있고요. 이제 그렇게 하다 보니까 또 장점은 이런 모든 것들을 하나의 다큐먼트, 그러니까 하나의 어떤 선언적인 매니페스트를 가지고 모든 필요한 일들을 정의하고 이 매니페스트만 던지면 플랫폼이 모든 것들을 자동으로 할 수 있는 그런 어떤 새로운 방법의 오픈스택을 설치, 운영하기 위한 굉장히 새로운 방법의 프로젝트라고 보시면 됩니다. 그래서 현재 SKT에서도 이 관련 프로젝트에 있는 에어쉽에 있는 아마다라는 프로젝트라든지 혹은 오픈스택 햄 같은 프로젝트는 저희가 개발하고 있는 코드를 100% 기여하고 있고 AT&T도 마찬가지고 실제로 프로덕션에 적용하는 것도 올해 내로 다 진행이 되는 굉장히 얼리 스테이지의 프로젝트지만 있는 컴포넌트들은 저희가 실제 상용 구축에 올해 내로 사용을 하는 그런 기술들로 이루어져 있습니다. 그래서 이 부분에 대해서 관심이 있으시면 뭐 저를 찾아오시거나 혹은 SK텔레콤 부스에서 여쭤보시거나 혹은 오후에 제 발표에 오시면 좀 더 내용을 들으실 수 있을 겁니다. 네, 감사합니다.
Thank you. So finally, going back to the 4 steps that we talked about, The last step is testing everything end to end, which is very, very important to all of this when you're bringing together new technologies. So within our community, we have made an investment in OpenLab, which is a testing platform. It's run by community members from primarily Huawei and Intel, and they're looking for more people to get involved. We also are collaborating with a cross-community group called OpenCI that's working across many different popular open source projects and helping to figure out how to test these projects better together. And finally, one of the other large work products from our work upstream in Kubernetes is getting OpenStack into the CNCF cross-cloud dashboard. And we think this is really important to help understand how OpenStack fits into this ecosystem and into this landscape. So we're very happy that this work was done. And we also are going to be participating in the new cloud provider SIG in Kubernetes as well. Actually, Chris is elected to help lead that SIG, which will be testing Kubernetes across different public clouds and private clouds, including OpenStack. So this was a very big milestone for us. And finally, we just want to say, all of this work that we have shared is done by many of you in this room, and there's a lot of activity right now and a lot of opportunity. So we invite you to join us to help turn open source software into open infrastructure. And you can do that at the next OpenStack Summit in Berlin, is in November this year. And then next year in April, we'll be in Denver. So hopefully you're able to attend an OpenStack Summit soon. And thank you.
Yeah, I just wanted to say a couple more things. First of all, about the user survey, I mentioned it earlier. We were in Beijing, China for OpenInfra Days China last week, and we encouraged the users there to take the survey, and over 100 people took it from China, so I know that more than 100 will take it here. And secondly, I just want to thank all of the organizers of this amazing event. They have done so much hard work, and it's really come together, so thank you to everybody involved in organizing.
Thank you.
Thank you.